No. I would just write down dot product of two vectors and then write down that little formula at the bottom. That is the formula for the dot product of two vectors. And the dot product is basically when you multiply two vectors together. The confusing thing about this is, and the thing that always throws people for a loop, is vectors are given by two numbers, like 6i plus 7j, or 5i minus 3j. Yet the dot product of two vectors is just one number. It's just one number. Which by itself is actually fairly worthless, but I'm going to be showing you how to use that dot product to find other things. Dot product of two vectors, yeah. Given by that bottom formula. And essentially it's just multiply the coefficient with the I values and add that to the product of the coefficient of the j values. And that's all it is. But nonetheless, write that down, and we will be exploring the uses of that dot product. So write that down, we're about to get started. Okay. You already have good mind. No. They never gave it to you? Well, never mind then. Okay, so here we go. Finding the dot product. Now notice, it's asking us for v dot v and v dot w. Just practice two different dots per question. So let's just jump straight into a hard one, like number 6. All right. Let's see, v dot w on number 6. V dot w, and this is number 6. So, -8. Okay. What? Right. Right. V dot w. -8 times -10 plus -3 times -5. It's just the a's, which is the number being multiplied by the I, plus the b's, the number being multiplied by the j. So what is that, 80 plus 15? Which gives you a dot product of 95. Are we missing Marco today?
Yeah.
Wait, yes, what?
I got another mistake.
Okay, that's pretty racist, but okay. Because no one was offended, I'll let it slide. Tanner's still out, huh? Anybody heard anything about Tanner? Is he doing okay? Oh, the flu. Ouch. Alright. V dot V. Yes. Say that again. Yeah. Yeah. Alright, V dot V. Here's the easiest way to do it. Since you're multiplying the same thing by itself, just square them both. -8 squared plus -3 squared. Kind of like magnitude, except not really. 64 plus 9, 73. Because V dot V, which is the second thing it asks us to find, V dot V. So essentially, you're doing the same thing as V dot W, but it's always going to be the same number times itself because it's the same vector. I guess I could have just done it this way. I guess the more professional way to write it would be V dot V, -8 times -8 plus -3 times -3. But because, what? Yeah, one for V dot W, one for V dot V. Other than number 7, is there a problem on the board someone would particularly like to see? For dot product. 1, 3, or 5. If it's missing an I or J, what do you think is the coefficient you're going to use? 0. 0. So number 7, on number 7, V dot W would be 5 times 0 plus 0 times 1. And what is the sum there? 0, which we're going to come back to that. There's something specific that's happening right there. And lastly, V dot V is 5 times 5 plus 0 times 0, which is 25. 5 times 5, 0 times 0. Questions? No questions over any of those or how you're going to do them? Sweet. Well, then let's just move right on. Click. Do I need to leave this on the board for a moment? Okay. All right. Multiple vector thingies. Number 9, U dot V plus W. Which one do you think comes first? Yeah, just order of operations. In fact, let's just jump straight into number 11. Number 11. Now, when I'm done, look at number 11 for a second. When I'm done, am I going to have an I and a J? What am I going to have after I do number 11? Like, how many numbers, how many I's, how many J's, anything like that. What am I going to have? You can tell me what my answer is going to look like. Well, actually, you may at one point. I don't think so. But this is just a number, correct? A dot product, and this is just a number. So when you're done with that whole equation, just one number is all you're going to have. Because anytime you use a dot product, that's all you get. So U dot V first. U dot V is 2 times 3 plus negative 1 plus 1. I'm sorry, times 1. Plus U dot W, which is 2 times 1 plus negative 1 times 4. So 6 plus negative 1 is 5. 2 plus negative 4 is negative 2. And what's my entire thing? 3. Anytime you use a dot product, you're just going to have a number. No more I's and J's. And since you use a dot product on all of those, that's it. Questions? Where's there 0? Where are we? Right here. Right here? 2I minus J. Right. But it's all multiplication in this one. So, Erica, right here. First off, U times V. So I took U and V, right? 2 times 3 plus negative 1 times positive 1. And then I did the same thing for U dot W. 2 times 1 plus negative 1 times positive 4, which is where then I just 6 plus negative 1, 2 plus negative 4, then I just added and what's J for 0? No, when there's not one at all, it's a 0. Like 5I, then the J would be a 0 because there's not one at all. But if there's just just like x plus 2 would have a coefficient of 1x, same thing. If there's one there at all, then it's 1. If it's missing altogether, like these, you see what I'm saying? So that didn't have a J or an, okay. All right, try this one on your own. Number 15, but I'm going to add to it.
Actually, that doesn't make any sense. Never mind. I'm not going to say that. Try 15. 15. If you have a question, I will be patrolling. You already have an answer for me? Yeah, answer. What? For 15? What you got? Not quite what I got. What's 24? I got 20. I got 20. Let's see. Let's explore the steps and see what happens. Now, U dot V just so happens to have already been a part of an above problem. So I'm just going to look at it there. U dot V, 2 times 3, plus 1 times negative 1. So that's 6 plus negative 1, which is 5. So it was just 4 times 5, it should have given you 20. Now, I started to add a plus W in here. Why wouldn't that have made any sense? Who can raise your hand and tell me why putting plus W would be yes? Yeah, it would be completely incompatible numbers. We would have had 20 plus something with I's and J's, and those just don't mesh. So very, very good. The problems for here? Sure. 4 dot times U dot V. So that's 4 times U dot V is 2 times 3 plus negative 1 times 1. So that's 4 times 6 plus negative 1, which I'm going to write over here next. So 4 times 5 equals 20. Questions on that? Yes. 13? Sure. Absolutely. 13. Well, I'm going to take more with me than I need to, but I'm going to take this to a separate slide. 13. Let's get rid of everything we don't need here. All of that. All of that. Okay. So, for U, now how do you think I'm going to distribute that 4? Sarah, how am I going to distribute the 4 in number 13? It's on the board. Yeah. That's right. So what's that going to give me? Minus 4j. That's right. And then I'm going to times that by V. So I'm going to dot product those two vectors. So it's 8 times 3 plus negative 4 times 1. 24 plus negative 4. Hey, 20 again. How about that? Did I answer your question, Jenny? Excellent. Sure. Do I need to leave this on the board? Number 9, u dot v plus w. Sure. I can try. Yes, if I skip something, you just let me know. Sometimes I do it without even noticing it. Let's see. Erase all that. Okay, so u dot v plus w. So first thing I'm going to do is plug in v and w. 3i plus j plus, I guess I'll put this in parentheses too, I plus 4j. So what's the trick to doing the first portion, Sarah? Okay. What is the trick to doing this first addition problem? Like terms, right. So there'll be u dot 3i plus 1i is 4i. 1j plus 4j is 5j. So u dot 4i plus 5j. Now I'm going to substitute u in. So all I've done here is take out u and put in what it actually equals. So that's 2 times 4 plus negative 1 times 5. I don't think I've skipped anything, but I could be wrong. 8 plus negative 5 gives us 3. Uh-huh. That one? Here? That's because that, yeah, I didn't write in the vectors. I just went straight to the multiplication portion. Yeah, sorry about that. Other questions? Okay. I believe the next thing we have to do, I'm not going to quite show you yet. The next thing we're going to do is we're going to take vectors and we're going to find out the angle between those vectors, which means, now let's look at like this example. Here's what I mean by angle between vectors. Now technically you could do all of this without the formula I gave you today because you know how to solve using trigonometry triangles. But I'm going to show you a specific formula, but first I'm going to show you the basis. So like u in this case is 2i minus j, right? So it's this vector, and j is 3i plus j. What? Yeah, v. So I'm looking for the angle between those two vectors, which would be this angle here. Now, if you can see how they would form a triangle, and by finding their magnitudes, you can find their sides, but I'm going to show you a shortcut to find that anyway. I'm going to show you a shortcut to finding that angle, but before I do, let's jump back for a second. Somebody think about the vectors on number 7 here, the one we did earlier. The vectors in number 7, who can describe for me what those vectors would look like in number 7? With one of these. Ryan. That's right. This one's going to be straight horizontal. This one's going to be vertical. What can I know about a horizontal line and a vertical line, or in this case vector, are what with each other? Perpendicular. Very good. Which means they form what kind of angle? 90. Does anybody remember what the dot product we got for those two was? 0. That's the first place your dot product is going to help you. If you ever get a dot product of 0, your angles are, now, technically they're perpendicular. But when you get out into three-dimensional space, there's so many different ways you can be perpendicular that the word the book uses is orthogonal, which is basically three-dimensionally perpendicular. Even though we're only dealing with 2 dimensions, I guess they're trying to get you in the right frame of mind for upper level calculus. So before we even look at this angle stuff, here's one set of directions you have. Use the dot product to determine whether the 2 vectors given in the problem are orthogonal, which means perpendicular. So all you have to do is basically find the dot product, and if any of them are 0, they're orthogonal. And if they're not 0, then they're not. That's all you have to do on that batch of problems. Dot product, 0 or not 0. That is the question. So, here we go. Let's look at one. How about 23? Again, all we're doing is finding L dot producto. So, V dot W is what we're finding. So that's 1 times 1 plus 1 times negative 1. And what is that dot product going to be? 0. 1 plus negative 1. Are they orthogonal? C. Yes, they are. I guess technically you would answer this question with orthogonal. Because it says, are they orthogonal? So you write orthogonal or not orthogonal. Man, that's a big word. Determine whether you can just put yes or no. That'll work too. Somebody pick out another one for us to work. $27. Okay, 27. V dot W. So first thing you take are your A values. 2 times negative 1 plus your B values. 2 times positive 1. And what's that sum going to be? 0. Negative 2 plus positive 2. Yay! So yay or nay? Well, I guess I answered that. Yes. They are orthogonal. Tartar sauce, yes. Negative 2 times positive 1, which would make this negative 4. So are they orthogonal? No! Thank you for catching that, Bruno. No, they are not. Without even punching any numbers in, take a gander at 29 and 31 and tell me what you think. Yeah. Anytime you have a straight I vector and a j vector, regardless of what their quantities are, one of them is going to be pure horizontal, the other is going to be, oh, actually, I thought that was a j as well. This one will be orthogonal. Straight horizontal, straight vertical, regardless of up or down, left or right. So, orthogonal. What about these two? That's right. Technically, they'd be parallel, even though they're going in opposite directions. One's going to the right, the other's going to the left. Not that it asks you that. You don't have to tell me parallel. And I don't know if there's a three-dimensional word for parallel. I don't think so. But that would just be no. No, they're not orthogonal. Yes, they are. Are there any questions in principle about what this slide is asking you to do? Okay. Well, then the last thing we have to do is it'll ask you, for some of them, just what's the angle between them. And here's the formula for that. I would just write down this portion. The formula for the angle between two vectors I have boxed in blue. There, you want to give a little right elbow. The formula, the angle between two vectors given inside that blue box. The angle between is cosine inverse of the dot product divided by the product of the two magnitudes. The product of the magnitudes on the bottom and the dot product on the top. a little hot in here, toasting my marshmallows. Okay. Does anybody need me to leave this on the board for a moment? Okay. Anybody doing anything exciting this weekend? You did? What'd you do, Eric? Oh, what is it? Where? I don't know. Anybody know where St. George Island is? No. That doesn't. What? Really? Okay. Well, where is it? At Memphis, obviously. Why did I even ask that? That's gonna be a good game. What's your question, Amanda? Oh, I can make it bigger. Would you like for me to do that? Just for fun, yes, we can. How's that? Is that better, Amanda? Okay. All right, here we go. Oh, that's right. Here we go. Find the angle between two vectors. So we'll work on one together, and I'll let you try one on your own. So first thing you need to find is the dot product. Now, remember, if the dot product is 0, we can just stop and immediately say that the angle between them is what? 90 degrees. Very good. So let's do number 17. First thing we need to find is V dot W. What? The formula? Oh, 17. Gotcha. You know, every day I get these from your book. Oh, okay. That's cool. Oh, right, for your notes. What? That's true. Darn my unpredictability. Alright, so first thing we have to find is V dot W, which is 2 times 3 plus negative 1 times 4. What's that dot product going to be? Dos? Dos. Good. Next thing we need to find is the two magnitudes. Who remembers how to find the magnitude of a vector? Well, that's if you're given coordinates. What's the easier way to do it if you're Pythagorean theorem? So for V, the magnitude of V, 2 squared plus 1 squared equals magnitude squared. So that'd be 4 plus 1 equals your magnitude squared. So that'd be square root of 5. For the magnitude of V, hence this symbol, which I changed to M because that's a lot to write down every time. I just took A squared plus B squared. Now technically B is negative 1, but since we're squaring it anyway, I just ditched the negatives. Because for the magnitude of a vector, you just need to, Pythagorean theorem of its sides. So A squared plus B squared. Now for the magnitude of W, let's see, that'd be 3 squared plus 4 squared. And what's M? Straight up 5, that's right. It's still hot in here. Angle time. What do you think you need to be in? That's right, because it says 1/10 of a degree. Cosine inverse of the dot product, which we already found, over the product of the magnitudes. And you just punch that whole thingamadoodle. Just remember, when you punch this into your calculator, you may have to close the parentheses on your radical 5. Well, you will have to do that. Make sure you're in degree mode. Ooh, hold on, guess time. Ooh. 107 degrees. What is it? Error is what? I think error sides on my side, so I'm going to go with a people center. Let's do that second. I got it. It's good. Now, I think it's like 79 point something, right?
Hey, I'll
Someone brought up an interesting point. An interesting point was brought up. When we punch this into the calculator, second cosine 2 divided by the square root of 5 times 5. Now, if I hit enter right now, why is it going to tell me error? What? That's right. The order of operations is going to do 2 divided by the square root of 5 and give you a number, and then multiply that by 5. But cosine inverse has to be of something less than 1. So you have to put your entire denominator in parentheses. Here we go. Enter. And 79.7 degrees. See? Okay. Try 21. Where's 21? Ooh, I can do this one. 42 degrees. Ooh, I'm feeling really good about this too.
You want to know my answer?
No.
I was going away last time. But you were going by the test.
21. 42. Oh, I'm so good about this.
Number 21?
Oh, yeah.
This one was 9.
Oh, you're off. I'm going to win this one. I'm so excited.
I could have been that guy who just didn't want to vote.
It's true. Supposed to be that guy. Thanks, Drew. 42.
No, I'm not going to lower it. I'm not lowering it. I'm just saying that.
I at least get one victory. So you need to be finding the dot product. You need to be finding the two magnitudes, and then you pile all that stuff into the formula. Second cosine. I mean, the problem we just did?
Yeah.
Second cosine. 2 divided by. Now open the parentheses, because you need to put your whole denominator in there. Now do square root of 5. Close the parentheses on your square root. Times 5. Close the parentheses on your whole denominator. And hit enter.
What did you get?
42.
I
know. I'm feeling really good about it. Oh, that's because you have a really fun calculator. And you're going to require a pair I like it. Good. What, is that on?
39.
Yeah.
What was it?
Well, I'll just say this. I was over. So if you went over me, you would win. Well, that's right. You can't go over. I would be so bad on the Price is Right. I'd be like $1,000. Paul or Bob, he'd be like, sorry, it was $9.99. 99. Then I go all psycho and everything. So, Sarah, Webb, have you had a chance to put it in? Okay, I'll wait. Well, I'll tell you why. Because if this was like 5'5", it would have been isosceles and therefore been 45, but the height was a little less than the horizontal. So I just subtract a little bit 45. Oh no. Oh yeah. That's what I'm talking about. No. Nearest Okay. Questions? Does anybody have any problems they need to ask about? Great. There you go.